I can start talking about the 17th century. I hope nobody finds that offensive. After I had invented PCR, I kind of needed a change, and I moved down to La Jolla and learned how to surf. And I started living down there on the beach for a long time. And when surfers are out waiting for waves, you probably wonder, if you've never been out there, like, what are they doing? Sometimes there's a 10, 15-minute break out there when you're waiting for a wave to come in. Well, they usually talk about the 17th century. You know, they get a real bad rap in the world. People think they're sort of lowbrows. But one day, somebody suggested I read this book. It was called the Air Pump. It's something like the Leviathan and the Air Pump. It was a real weird little book about the 17th century. And I realized the roots of the way I sort of thought was just the only natural way to think about things. That, you know, I was born thinking about things that way, and I had always been like a little scientist guy. And when I went to find out something, I used scientific methods. I wasn't real surprised, you know, when they first told me how you were supposed to do science, because I'd already been doing it for fun and whatever. But it never occurred to me that it had to be invented, and that it had been invented only 350 years ago. You know, it was like it happened in England and Germany and Italy, sort of all at the same time. And the story of that I thought was really fascinating. So I'm going to talk a little bit about that and what exactly is it that scientists are supposed to do. And it's a kind of what, you know, Charles I got beheaded somewhere early in the 17th century, and the English set up Cromwell and a whole bunch of Republicans or whatever, not the kind of Republicans we have, but they changed the government, and it didn't work. And Charles II, the son, was finally put back on the throne of England. But he was really nervous because his dad had been, you know, beheaded for being the King of England. And he was nervous about the fact that conversations that got going in like bars and stuff would turn to weird. I mean, it's hard to believe, but people in the 17th century in England were starting to talk about, you know, philosophy and stuff in bars. I mean, they didn't have TV screens in there. They didn't have any football games to watch. And they would get really pissy, and people would spill out into the street and fight about issues like whether or not it was okay if Robert Boyle made a device called a vacuum pump. Now, Boyle was a friend of Charles II's. He was a Christian guy during the weekends, but during the week he was a scientist. And which was, back then it was sort of, you know, well, you know, if you make this thing, he made this little device kind of like a bicycle pump in reverse that could suck all the air out of it. You know what a bell jar is? When it seems like you can pick it up, put it down, and it's got a seal, and you can see inside of it, so you can see what's going on inside this thing. But what he was trying to do was pump all the air out of there and see what would happen inside there. I mean, I think one of the first experiments he did was he put a bird in there. And you know, people really, in the 17th century, they didn't really understand the same way we do about, you know, this stuff is a bunch of different kinds of molecules, and we breathe it in for a purpose and all that. I mean, the fish don't know much about water, and people didn't know much about air. But Boyle started exploring it. One thing, he put a bird in there, and he pumped all the air out, and the bird died. So he said, And he called what he had done as making they didn't call it a vacuum pump at the time. Now you call it a vacuum pump. He called it a vacuum, right? And immediately he got into trouble with the local clergy, who said, "You can't make a vacuum." And Aristotle said that nature abhors one. I think that was a poor translation, probably, but people relied on authorities like that. And, you know, Boyle says, well, shit, I make them all the time. I mean, whatever that is that kills the bird, I'm calling it a vacuum. And the religious people said that if God wanted you to make he says God is everywhere. That was one of their rules, is God is everywhere. And a vacuum, there's nothing in a vacuum. So God couldn't be in there. So therefore, the church said, you can't make a vacuum, you know. And Boyle said, bullshit. I mean, you want to call it godless, you know, you call it godless, but that's not my job. I'm not into that. I do that on the weekends. And like, what I'm trying to do is figure out what happens when you suck everything out of a compartment. And he did all these cute little experiments. Like he did one with, he had a little wheel in there, like a fan that was sort of loosely attached so it could spin by itself. He had another fan opposed to it that he had like a, I mean, the way I would have done this would be like a rubber band, you know, around a Tinker Toy kind of fan. I don't know exactly how he did it, but I've seen the drawings of it. But it's two fans, one which he could turn from outside after he got the vacuum established. And he discovered that if he pulled all the air out of it, the one fan would no longer turn the other one, right? Something was missing, you know. I mean, it's kind of weird to think that somebody would have to do an experiment to show that, but that was what was going on at the time. And like there was big arguments about it in the, you know, the gin houses and in the coffee shops and stuff. And so Charles started not liking that. Charles II was kind of saying, you know, you should keep that. Let's make a place where you can do this stuff, where people don't get so, you know, we don't want to get the people mad at me again. And so, because when they started talking about religion and science and stuff like that, that's what it sort of got his father in trouble. And so Charles said, I'm going to put up some money, give you guys a building, come here and you can meet in the building, but let's don't talk about religion in there. And that was fine with Boyle. He said, okay, we're going to start having these meetings, and anybody who wants to do science, this is about the time Isaac Newton was starting to whip out a lot of really interesting things, and there was all kind of people that would come to the Royal Society, they called it. You had to be dressed up pretty well. It wasn't like a TED conference. That was the only criteria, was that you looked like a gentleman. Anybody could come in. You didn't have to be a member then. And so they would come in and you would do it. Anybody was going to show an experiment, which is kind of a new word at the time, demonstrate some principle. They had to do it on stage where everybody could see it. So the really important part of this was you were not supposed to talk about final causes, for instance. And God was out of the picture. The actual nature of reality was not at issue. You're not supposed to talk about the absolute nature of anything. You were not supposed to talk about anything that you couldn't demonstrate. So if somebody could see it, you could say, here's how the machine works, here's what we do, and then here's what happens. And seeing what happens, it was okay to generalize and say, I'm sure that this will happen anytime we make one of these things. And so you can start making up some rules. You say anytime you have a vacuum state, you will discover that one wheel will not turn another one if the only connection between them is whatever was there before the vacuum, that kind of thing. Candles can't burn in a vacuum, therefore probably sparklers wouldn't either. It's not clear that actually sparklers will, but they didn't know that. They didn't have sparklers, but they... You can make up rules, but they have to relate only to the things that you've been able to demonstrate. And most of the demonstrations had to do with visuals. Like if you do an experiment on the stage and nobody can see it, they can just hear it. They would probably think you were freaky. I mean, reality is what you can see. Kind of that wasn't an explicit rule in the meeting, but I'm sure that was part of it. You know, if people hear voices and they can't see them associated with somebody, that person's probably not there. But the general idea that you could only really talk about things in that place that had some kind of experimental basis. It didn't matter what Thomas Hobbes, who was a local philosopher, said about it, you know, because you weren't going to be talking final causes. What was happening here in the middle of the 17th century was that what became my field, science, experimental science, was pulling itself away, and it was in a physical way because we're going to do it in this room over here. But it was also, it was an amazing thing that happened. Science had been all interlocked with theology and philosophy and mathematics, which is really not science. But experimental science has been tied up with all those things. And the mathematics part and the experimental science part was pulling away from philosophy and things, we never looked back. It's been so cool since then. I mean, it just untangled a thing that was really impeding technology from being developed. And I mean, everybody in this room now, this is 350 short years ago. Remember, that's a short time. It was 300,000 probably years ago that most of us, the ancestors of most of us in this room, came up out of Africa and turned to the left. You know, I mean, the ones that turn to the right, there's some of those in the Japanese translation. But that happened a long time ago compared to 350 short years ago. But in that 350 years, the place has just undergone a lot of changes. In fact, everybody in this room probably, especially if you picked up your bag, some of you I know didn't pick up your bags, but if you picked up your bag, everybody in this room has got in their pocket or back in their room something that 350 years ago kings would have gone to war to have. I mean, if you can think how important, well, if you have a GPS system and there are no satellites, it's not going to be much use. But like, you know, if somebody had a GPS system in the 17th century, some king would have gotten together an army and gone to get it, you know. If that person,
the teddy bear.
That they might have done it for the teddy bear, yeah. But all of us own stuff. I mean, individuals own things that kings would have definitely gone to war to get. And this is just 350 years, not a whole lot of people doing this stuff. You know, the important people, you can almost read about their lives, about all the really important people that made advances, you know. And I mean, this kind of stuff, you know, all this stuff came from that separation of this little sort of thing that we did. Now, when I was a boy, was born sort of with this idea that if you want to know something, you know, maybe it's because my old man was gone a lot and my mother didn't really know much science, but I always thought if you want to know something about stuff, you do it, you make an experiment, you know, you get like, I just had a natural feeling for science and setting up experiments. I thought that's the way everybody had always thought. I thought anybody with any brains will do it that way. It isn't true. I mean, there's a lot of people, and you know, I was one of those scientists that was gotten in trouble the other night at dinner because of the postmodernism thing, and I didn't mean, you know, where is that lady? Yeah. I mean, I didn't really think of that as an argument so much as just a lively discussion. You know? I didn't take it personally, but I naively had thought until this surfing experience started me into the 17th century, I thought that that's just the way people thought, and everybody did, and they recognized reality by what they could see or touch or feel or hear. At any rate, when I was a boy, like, for instance, I got this little book from Fort Sill, Oklahoma. This is about the time that George Dyson's dad was starting to blow nuclear and thinking about blowing up nuclear rockets and stuff. I was thinking about making my own little rockets, and I knew that little frogs had aspirations of space travel just like people. And I was looking for a propulsion system that would like make a rocket like maybe about 4 feet high go up a couple of miles. And I mean, that was my sort of goal. I wanted it to go out of sight, and then I wanted this little parachute to come back with the frog in it. And I got this book from Fort Sill, Oklahoma, where it was a missile base. They sent it out for amateur rocketeers, and it said in there, "Do not ever heat a mixture of potassium perchlorate and sugar." And you know, that's what you call a lead, sort of. And you say, well, let's see if I could get a hold of some potassium chlorate and sugar, perchlorate and sugar, and heat it. It'd be interesting to see what it is they don't want me to do. How is it gonna work? And we didn't have, like, my mother presided over the backyard from an upstairs window where she would be ironing or something like that, and she was usually just sort of keeping an eye on it. And if there was any puffs of smoke or out there, she'd lean out and admonish us all not to blow our eyes out. That was her. She had, you know, that was kind of the worst thing that could happen to us. That's what I thought. As long as I don't blow my eyes out, I'm going to not care about the fact that it's prohibited from heating this solution. I'm going to do it carefully, but I'll do it. It's like anything else that's prohibited. You do it behind the garage, sort of. And like, so I went to the drugstore and I tried to buy some potassium perchlorate, and you know, it wasn't unreasonable then for a kid to walk into a drugstore and buy chemicals. I mean, nowadays, no, man. I mean, they check your shoes and like. But then it wasn't, and they didn't have any, but the guy had potassium. I said, what kind of salts of potassium do you have? And he had potassium nitrate. I said, that might do the same thing, whatever it is. I'm sure it's got to do with rockets, or it wouldn't be in that manual. And so I did some experiments. You know, I started off with little tiny amounts of potassium nitrate and sugar, which was readily available. And I mixed it in different proportions, and I tried to light it on fire. And just to see what would happen if you just mixed it together. And they burned, but it burned kind of slow, but it made a nice smell compared to other rocket fuels I had tried that all had sulfur in them. And it smelled like burnt candy, kind of. And then I tried the melting business, and I melted it. And then it melted into a little sort of syrupy liquid, brown, and then it cooled down to a brick hard substance that when you lit that, it went off like a bat. I mean, the little ball of that stuff that had cooled down, you light it and it would just start dancing around the yard. And I said, there is a way to get a frog up to where he wants to go. You know? So I started developing, you know, George's dad had a lot of help. I just had my brother, but it took me about, I'd say, 6 months to finally figure out all the little things. There's a lot of little things involved in making a rocket that it'll actually work, even after you have the fuel. But you do it by you do experiments. And you write down things sometimes. You make observations, you know, and then you slowly build up a theory of like how this stuff works. And it was, you know, I was following all the rules. I didn't know what the rules were. So I'm a natural born scientist, I guess, or some kind of a throwback to the 17th century, whatever. But at any rate, we finally did have a device that would reproducibly put a frog out of sight and get him back alive. And we had not... I mean, we weren't frightened by it. We should have been, because it made a lot of smoke and it made a lot of noise, and it was powerful, you know, and once in a while they would blow up. But I wasn't worried, by the way, about, you know, the explosion causing the destruction of the planet. I hadn't heard about the 10 ways that we should be afraid of things. By the way, I could have thought, I better not do this because they say not to. You know, and I better get permission from the government. If I'd have waited around for that, the frog would have died, you know. At any rate, I bring that up because it's a good story, and he said, tell personal things, you know, that's a personal. I was going to tell you about the first night that I met my wife, but I thought that'd be too personal. So I've got something else that's not personal to tell, but that process is what I think of as science, see, where you start with some idea, and then instead of like looking up every authority that you've ever heard of, I mean, sometimes you do that if you're going to write a paper later. You want to figure out who else has worked on it. But in the actual process, you get an idea. Like when I got the idea one night that I could amplify DNA with 2 oligonucleotides, and I could make lots of copies of some little piece of DNA, you know, the thinking for that was about 20 minutes. While I was driving my car. And then instead of going, I went back and I did talk to people about it, but if I'd listened to what I heard from all my friends who were molecular biologists, I would have abandoned it. You know, if I'd have gone back looking for an authority figure who could tell me it would work or not, he would have said, no, probably won't. Because the results of it were so spectacular that if it worked, it was going to change everybody's goddamn way of doing molecular biology. Nobody wants a chemist to come in and poke around in their stuff like that and change things. But if you go to authority, and you don't always get the right answer. See, but I knew you go into the lab and you try to make it work yourself, and then you're the authority, and you can say, I know it works because right there in that tube is where it happened, and here on this gel there's a little band there that I know that's DNA, and that's the DNA I wanted to amplify, so there. So it does work. You know, that's how you do science. And then you say, well, what can make it work better? And then you figure out better and better ways to do it. But you always work from like facts that you have made available to you by doing experiments, things that you could do on a stage. And no tricky shit behind the thing. I mean, it's all, you got to be very honest with what you're doing if it really is going to work. I mean, you can't make up results and then do another experiment based on that one. So you have to be honest. And I'm basically honest. I have a fairly bad memory, and dishonesty would always get me in trouble. So I've just sort of been naturally honest and naturally inquisitive, and that sort of leads to that kind of science. Now, let's see. I've got about 5 minutes left, right? Okay, I want to tell you, all scientists aren't like that, you know, and there is a lot. there's a lot's been going on since Isaac Newton and all that stuff happened. One of the things happened right around World War II, in that same time period before and surely as hell afterwards. Government realized that scientists aren't little strange dudes that, you know, hide in ivory towers and do ridiculous things with test tubes. Scientists, you know, made World War II, as we know it, quite possible. I mean, they made faster things. They made bigger guns to shoot them down with. You know, they made drugs to give the pilots if they were broken up in the process. They made all kinds of, I mean, they finally one giant bomb to end the whole thing, right? And everybody stepped back a little and said, you know, we ought to invest in this shit. Because whoever has got the most of these people working in the best places is going to have a dominant position, at least in the military, and probably in all kinds of economic ways. And they got involved in it. And the scientific industrial establishment was born. And out of that came a lot of scientists who were in there for the money, you know, because it was suddenly available. And they weren't the curious little boys that liked to put frogs up in the air. They were the same people that later went into medical school, you know, because there was money in it, you know, and later then they all got into business. I mean, there's waves of going into your high school person said, you want to be rich, you know, be a scientist, you know, not anymore. You want to be rich, you be a businessman. But a lot of people got in it for the money and the power and the travel. It's back when travel was easy. And like, those people don't think, they don't always tell you the truth. You know, there is nothing in their contract, in fact, that makes it to their advantage always to tell you the truth. So, and these are the people I'm talking about are people that like, they say they're a member of the committee called, say, the Intergovernmental Panel on Climate Change, and they have these big meetings where they try to figure out how are we going to continually prove that the planet is getting warmer when that's actually contrary to most people's sensations. I mean, if you actually measure the temperature over a period, I mean, the temperature has been measured now pretty carefully for about 50, 60 years. Longer than that it's been measured, but in really nice, precise ways, and records have been kept for 50 or 60 years. And in fact, the temperature hadn't really gone up. It's like the average temperature has gone up a tiny little bit because the nighttime temperatures at the weather stations have come up just a little bit. But there's a good explanation for that, and it's that the weather stations are all built outside of town where the airport was, and now the town's moved out there, there's concrete all around, and they call it the skyline effect. And most responsible people that measure temperatures realize you have to shield your measuring device from that, and even then, you know, because the buildings get warm in the daytime and they keep it a little warmer at night. So the temperature has been sort of inching up. It should have been, but not a lot. Not like, you know, the first guy that got the idea that we were going to fry ourselves here, actually, he didn't think of it that way. His name was Svante Arrhenius. He was Swedish, and he said if you double the CO2 level in the atmosphere, which he thought, this is 1900, the temperature ought to go up about 5.5 degrees, he calculated. He was thinking of the Earth as kind of like, you know, like a completely ice-insulated thing with no stuff in it, really, just energy coming down, energy leaving. And so he came up with this theory, and he said, this will be cool because it'll be a longer growing season in Sweden, you know, and the surfers liked it. The surfers thought that's a cool idea because it's pretty cold in the ocean sometimes. But a lot of other people later on started thinking it would be bad, you know, but nobody actually demonstrated it, right? I mean, the temperature as measured, and you can find this on our wonderful internet. You just go and look for all the NASA's records and all the Weather Bureau's records, and you look at it yourself, and you'll see the temperature has just, the nighttime temperature measured on the surface of the planet has gone up a tiny little bit. So if you just average that in the daytime temperature, it looks like it went up about 0.7 degrees in the century, but in fact it was just coming up, it was the nighttime. The daytime temperatures didn't go up. So in Arrhenius' theory and all the global warmers, they would say, yeah, it should go up in the daytime too, if it's the greenhouse effect. Now, people like things that have like names like that, that they can envision it, right? I mean, but people don't like things like this. Like you don't get all excited about things like the actual evidence, you know, which would be evidence for strengthening of the tropical circulation in the 1990s. It's a paper that came out in February, and most of you probably hadn't heard about it. Evidence for large decadal variability in the tropical mean radiative energy budget. Excuse me. Those papers were published by NASA and some scientists at Columbia and Veliky and a whole bunch of people, Princeton. And those two papers came out in Science magazine, February the 1st. And the conclusion in both of these papers, and then also the Science editor's description of these papers for the quickie, is that our theories about global warming are completely wrong. I mean, what these guys were doing, and it's what this NASA people have been saying this for a long time. They say if you measure the temperature of the atmosphere, it isn't going up. It's not going up at all. We've been doing it very carefully now for 20 years from satellites, and it isn't going up. And in this paper, they showed something much more striking, and that was that they did what they call a radiation. I'm not going to go into the details of it, actually. It's quite complicated, but it isn't as complicated as they might make you think it is by the words they use in those papers. If you really get down to it, they say, the sun puts out a certain amount of energy. We know how much that is. It falls on the earth gives back a certain amount. When it gets warm, it makes redder energy, like infrared, like something that's warm gives off infrared. The whole business of the global warming trash, really, is that if there's too much CO2 in the atmosphere, the heat that's trying to escape won't be able to get out. But the heat coming from the sun, which is mostly down it's like 350 nanometers is where it's centered, that goes right through CO2. So you still get heated, but you don't dissipate any. Well, these guys measured all those things. I mean, you can talk about that stuff, and you can write these large reports, and you can get government money to do it, but they actually measured it, and it turns out that in the last 10 years, that's why they say decadal there, that the energy, the level of what they call imbalance has been way the hell over what was expected. Like the amount of imbalance, meaning heat's coming in and is not going out, that you would get from having double the CO2, which we're not anywhere near that, by the way. But if we did in 2025 or something have double the CO2 as we had in 1900, they say it would increase the energy budget by about, in other words, 1 watt per square centimeter more would be coming in than going out. So the planet should get warmer. Well, they found out in this study, these two studies by two different teams, that 5.5 watts per square meter have been coming in from 1998, 1999, and the place didn't get warmer. So the theory's complete. These papers should have been called the end to the global warming fiasco, But they're concerned, and you can tell they have very guarded conclusions in these papers because they're talking about big laboratories that are funded by lots of money and by scared people. If they said, you know what, there isn't a problem with global warming any longer, so we can, they're funding. If you start a grant request with something like that, you say, global warming obviously hadn't happened. If they actually said that, I'm getting out. I'll stand up too, and I'll slowly get there. They have to say that. They have to be very cautious, but what I'm saying is you can be delighted because the editor of Science, who is no dummy, and both of these fairly professional, really professional teams have come to the same conclusion, and in the bottom of the lines in their papers they have to say what this means is that what we've been thinking was the global circulation model that would predict that the Earth is going to get overheated and stuff, that it's all wrong. It's wrong by a large factor. It's not by a small one. They just misinterpreted the fact that the Earth, there's obviously some mechanisms going on that nobody knew about because the heat's coming in and it didn't get warmer. So the planet is a pretty amazing thing. It's big and horrible and big and wonderful, and it does all kinds of things we don't know anything about. So, I mean, the reason I put those things all together, I was thinking, here's the way you're supposed to do science. Some science is done for other reasons than just curiosity. And there's a lot of things like global warming and ozone hole and, a whole bunch of scientific public issues that if you're interested in them, you have to get down to the details and read the papers called Large Decadal Variability in the Tropics. You have to figure out what all those words mean. And if you just listen to the guys who were hyping those issues and making a lot of money out of it, you'll be misinformed and you'll be worrying about the wrong things. Remember the 10 things that are going to get you. The one of them, and the asteroids is the one I really agree with there. I mean, you got to watch out for asteroids. Okay, thank you for having me here.
At Rolex, the pursuit of excellence is a passion. At the heart of every timepiece we make is the Rolex movement. 100% conceived by Rolex's research and development teams. Every Rolex movement undergoes an exacting production process. One that can take well over a year to complete. It begins with hundreds of finely manufactured components. And after careful assembly and minute adjustments, all that remains is the careful positioning of the oscillator. This is the heartbeat of every Rolex, the moment a Rolex truly comes to life. A Rolex isn't just a watch. It's technology emboldened by the human spirit. The Rolex movement. An entirely Swiss-made jewel. The pearl in every oyster that is a Rolex.